Okay, so let's look at some application problems with trigonometry. Okay, now you should recall that the domain, range, and period of the sine function and the cosine function are the same due to the unit circle. Domain, all real numbers, range between -1 and 1 inclusive, period of 2 pi or 360 degrees, right? And the period of a function is how long it takes for the function to repeat its pattern. All right, so here we have an interesting function, right? That if we take this function p of t and we graph it, it actually graphs as a sinusoid, right? So it graphs where it would be able to follow a sine function or a cosine function, right? And in more advanced level classes, we can talk about how we can figure out what the exact equation is that could model this as well. We'll say that this function models the motion for a weight suspended from a particular spring, and that P is going to be the displacement from the equilibrium position in centimeters, and T is the elapsed time in seconds, right? And we have the maximum values, right? We've got the maximum values at a couple of points that are given, and we have the minimum value at a point that's given. Okay. So first question, fairly straightforward. How many times does the weight pass through the equilibrium position in the first 2 seconds? Well, our justification probably should be what we think of first, and that is we pass through the equilibrium if we cross the x-axis, right? That this center line we're going to call our equilibrium. Well, the center line is the x-axis. So how many times does that happen in the first 2 seconds, right? In the first 2 seconds, that happens once, twice, 3 times, right? Therefore, this occurs 3 times. Okay, now we want to state the time at which the weight passes through the equilibrium point for the second time, and to mark this clearly on the graph. And we're going to give the answer to the nearest hundredth of a second, right? So we care about that time. We cross through the equilibrium a second time. All right. Well, what we can do is we can come over and get our graph, right? We can say y equals, and we need to type in our graph. So let's go ahead and clear out what we had here before. And it seems that we've got, what is that? 5 sine, 4 times my variable, minus 2 cosine, 4 times my variable. Okay, and if I look at this, I'm looking basically from 0 to 3, between -5 and 5, a little bit more than that. So I can go to my window and say, let's go ahead and look at my window from 0 to 3, tick marks every half unit, and then let's go from -6 to 6 to be able to see everything on the y. And I'll go ahead and put my graph in, and I can see my graph is looking like what I have there. And I want to figure out this second point of intersection. So I can go second, trace, right, find the 0, right, and I can arrow to the left of my 0, and I can arrow to the right of my 0, and press enter on my TI-84, and I have that it seems to be to 2 decimal places, 0.88. And so, state the time at which the weight passes through the equilibrium point for the second time to the nearest hundredth of a second. That time is going to be 0.88 seconds. Okay, and we've marked that point clearly on the graph. Okay. So that is our first problem. We'll look at number 4 in our next video.